Do you have the screen now or no?
Yes,
Yeah.
yes. I just started sharing that.
I don't know what happened to my cursor is abnormally large.
So,
Okay.
I have my monitor, so you should be seeing my. Are you seeing my data?
Yep.
Okay, okay. Let me just close and open the tab. Okay, so basically, I went ahead and when me and Andrew had our meeting, we discovered that both of us we had some categorical variables. In my case, I had to format when you see all these ones, one, and all these numbers. This pretty much I made a legend. I want to go over how I codify the data
Mm.
because the regressions they were thrown off, so I'm having some problems with that. So basically, I'm analyzing the years 2010 till 2020,
Mm-hmm.
and I'm using the exporting countries of China, India, Sri Lanka, and Kenya, and the importing countries of Russia, the UK, and the US. So I clean my data, I organize it in a sort of a linear relationship between before throwing my regression. Right now, you're seeing the data organized as I used it before I ran the model. So pretty much, looking at my dependent variable, I'm looking at how the TS4 volume is influenced by multiple factors. In this case, I'm looking at the importing country's GDP, the price of crude oil, the percentage of tariffs that is imposed by the importing country to the exporting country. Also, analyzing how the tea production, which is measured in tons, is also how it changes due to these factors, and also the exchange rates, and there's also the logistic performance index for each of the exporting countries. Now, so this is how I organize my data. And now
One second,
I
or 1 second.
Mhm.
Okay, before you go further, I just want to mention what happened to population.
Oh, wait, population.
You can put
Oh,
it later.
I didn't include population in my data. I'm using GDP. I'm not including
But
population.
you need population because larger populations will have larger GDP, and you don't want it to be explained by larger population. You want it to be explained by productivity per
Yeah, so
person.
maybe
So that's why you need to
yeah,
have the population.
so
So that's the
I'm
control.
definitely gonna
That's like a
include it.
control variable. Hmm?
Write that down here.
That's off. That's just off the bat. I maybe there are other issues, but
Yeah, so I'm gonna wanted to start showing the models how I did it. So I'm using the log for all my models. I'm using a logarithmic relationship. The reason that I'm using this is because the the numbers and the amount that I'm working, there's such huge numbers, and also I'm dealing with percentage in tariff that when I try to run the regression without using a logarithmic relationship and then divided it by 100, I was getting extreme negative values, and Excel was not letting me run the regression. So I'm gonna start with the first model that I have here. So this first model is basically the relationship of how the GDP, tariff, and exchange rate influence the exporting volume of tea. Now, all of my model, I am noticing that the R square is very low. So right off the bat, I know that I have to work with that. And in the area of analysis and the future recommendation, one of the observations that Andrew was giving me and that we agreed upon is that right now I have 132 observations. That is the size of my that's my N value. So maybe for future recommendation, I could use another decade or include other variables of control to sort of solidify the statistical power of this model. But my main issue that I have with my models that I need to look into them is the fact that all of them they don't pass the 20% of the R square. This model is the one that has the highest R square and still pretty low. So I'm trying to because in theory, when I thought about the model, it would make sense. I had the predictions that at a higher tariff, there's going to be a negative relations, that GDP would serve like an income variable. But when I ran the regression, it pretty much tells me that there is no relationship between the variable, even though in theory there should be a relationship. So I'm sort of struggling to explain what is the la dicotomía between the what I'm finding because it makes sense in practice from what I have observed, not just in my experience as being in the tea industry, but also in the literature. But I'm trying to see if maybe the way that I organize the data or by me having categorical variable, that's what threw my data off because for me, it's not making that much sense. So right now, I'm in the process of trying to make sense of why the models they're giving me these values. For example, this other model has to do with the GDP, oil prices, and tariff. This is more of a model where I put the second part of my research question, which is logistic cost. Logistic cost being measured by the crude oil prices across the decade that I'm analyzing. And my other model, which is a model that has to do with the efficiency, infrastructure, and tariffs, which is basically GDP, logistic performance index, and tariffs, also gave me a low R square statistic. And the fourth model, I'm going to have to revisit it because I was going to use the price variable, but then I realized that in my data, well, I'm calling the fifth model, had to do, this one has to do with tea production, oil prices, and tariffs, and how tea export volume, what is the relationship between the tea production in tons, oil prices, and tariffs, how they influence the export volume. So it's sort of like the supply aspect of the relationship. And the fifth model, which I haven't run it yet because it has to do with price, I am missing the price data for China. So this is the only model that I am currently missing, which is the unit value model. So pretty much that's what I've done with my data. And I know that for the purpose of this paper, this is an exploratory study. I want to expand this research as part of my articles and my dissertation. And I for sure I have to add, for example, population to use it as a better control variable. I was also thinking about perhaps climate because even though I have the data of the production, the exportation, the auction data for price of tea, maybe if I can um, despejar or separate other variables such as climate or time-lapse series, even though the first model is a gravity model that sort of captures that time lapse. I'm I'm just trying to understand the what the data is trying to tell me. I know that given the number of observations that I have, it something that could be expected is not to have such a high statistical explanatory power because at this stage it's something more like an exploration. But that's pretty much what I'm trying to obscure. And of course, I'm have to finish running the diagnostic because I was breaking my head just trying to understand the the regressions and why they're giving me such low values.
Okay.
And the thing that I wanted to discuss you that I will discuss it with Andrew is I'm suspecting that these two columns, the year, country, and the importing country, Excel is interpreting this as numerical value because it wouldn't understand it as a categorical. So maybe if there's a way that I can, because I'm pretty sure that's also one of the things that's throwing off my data, having such low numbers in relationship to the billions and tons of numbers that I have in the other data. So now I'm just trying to see uh, what way or how can I use the function? Because Andrew showed me that in stat data, it's easy to use categorical, but I don't have stat data and we're not using it for this course. So the main challenge that I'm facing, I'm sure Andrew is also in the same boat, is the fact that we have categorical value in the forms of years and country, and Excel doesn't really have a function, or at least I'm not familiar of how to codify it. So I gave it numbers and I made a legend for it, but I suspect that that is could be one of the reasons that my regression models are being thrown off by these categorical
Okay,
variables.
okay, Christopher. So you used a categorical variable, but did you make dummies? You need
Well,
to make dummies
the
to identify which of the ones. So you made a variable that's categorical, but you should be using a dummy to identify which year, the effect of each year. Otherwise, it's going to treat it like, and I guess Andrew was getting at that too. It's going to treat it like a continuous variable, and that's not really what. I mean, you're going to get the effect of one additional year, but if you, that's basically what you're going to interpret it as for each additional year, the coefficient's going to tell you the impact on your dependent variable. But if you want to capture the effect of individual years, like the year of tariffs or imposed or things like that, you're going to have to use categorical. So 2010 would be a dummy, 2011 will be a dummy. So you have enough data to do that. You follow me? To make a dummy
yes,
0, 1 dummy for each year that you wanna test against the
so
other years.
So I will have to do it like separately because the reason that I did it this way is because pretty much by using the one, it would be 2010. But I have three countries that are being studied for each
Sorry,
year
sorry,
in
Christopher,
relation to,
show me the coding for year. Show me the
yeah,
codes.
sure. So
So sorry, don't say anything. 1 second. So
fine,
one,
fine.
2, 3, 4, 5. Yeah, no, no, no. I need you to make 2010 a 0 or a 1 and make it the variable called call year 2010. You make a variable called year, like YR 2010, or give it a name like that, because I don't know that. Yeah. Give the late, like the variable name YR 2010, something like that. Spell YR 2010, not as one word. That would be the variable name. You don't have to write that. Just put it together.
No, no,
YR.
no, 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 no. I'm just taking notes because I also have an in my monitor. I'm also doing it so that I can.
Okay, so you're gonna have to put that in as a dummy if you think you want to see the effect of the year 2010. If you want to see the effect of the year 2011. I mean,
2011.
yeah. So you individually pick up the effects, and so you need to account for each of the years. Otherwise, the way you have it set up is just going to tell you the per year effect. It's not exactly what you're getting at. The other thing is you talked about lags. You didn't put any lags in, did you? So this is time series data where you think a lag effect may play a role, right? Delay of tariff impact or imposition or
Yeah, that's pretty much what I'm trying to evaluate in the first model, which is a gravity model.
did you create
But
the lag variable?
no, I didn't create it because I was thinking that by organizing that way, we'll be able to capture the effect the way they organize the data. But
Okay, let,
I
let me
have
let
to
me take a
create that.
brief. I want to take just a moment to show you guys something. I've been meaning to
Yes.
go through this with you. And this is for everyone, all right? So I want to create like a table. So I just asked like AI to make me a table of the most important things regarding the ordinary least squares assumption. This is great. You know, I couldn't have done this 2 years ago, so it's really nice that I get to see um the I guess it's always hard for me to remember exactly the impact of violating assumptions and the importance of the assumptions, but I know you have to check them and how to check them. So I'd like you to do this, I've mentioned, in Excel, just because the Z statistics goes through using Excel, and this doesn't have to be so sophisticated. It's just to have you guys go deep with a this very important set of assumptions. That's what I want you to go through, verify them, validate them, that they're violated, and then just contemplate how they've affected your results. So you found out that, yeah, you have low R squared. So where does low R squared come from? Why is that happening? Well, you're missing variables. Clearly, you're missing variables. You misspecified your model. When you do that, everything goes into the error term, and you have some sort of omitted variables bias. And that's affecting your coefficients. We didn't even talk about the signs. When you look at the coefficient, you look at the R squared, but you have to look at the intended signs, positive or negative, positive or negative. And when I talk about bias coefficients, it means that what you thought was going to be a positive relationship actually turns out to be a negative one, or it's not even significant. Well, actually, no, the bias would be the positive or negative being wrong. And then the fact that it's not significant is because the coefficient standard errors are either, well, they're too big. They're too big, and it's impossible to get them to be significant, because the idea of the coefficient test, when you're looking at the p-values, right? When you're looking at the p-values, let me put my camera on. Hold on. So when you're actually, can you stop for a second? Can you stop?
Yeah. Right.
Yeah, it's okay. So when you're looking at the p-values, okay, when you're looking at the p-values, you look at you look at the p-value, and the p-value shows that if it's significant, it means that your coefficient is different from zero. If the standard errors are too wide, it's going to show your coefficient is no different from zero, because zero is going to end up in the confidence interval if you guys are following me with the statistics. And if you're not, I can spend more time talking about the statistics, but your coefficient is going to have a large standard error, means the confidence interval will be too big. So the coefficient won't be different from zero, and you won't have a significant result. So if standard errors are too big, that's a problem. If your coefficients are biased, that's a problem. And that could be all caused by some of your assumptions being violated. So for instance, let me just show you. So I just pulled something up on AI. Where is it? Where's my, hold on. I made this table here. So I just asked for a table of the assumptions and the consequences. And all this information is in the Z statistics video, but this is a summary, right? So the linearity assumption is an assumption about the specification of the model. So you guys, it's very important for me to see your model. Then we can talk about the model. We can deliberate if variables are missing. What's the consequence of variables missing? Is that you will have bias and inconsistent coefficient estimates. Bias means the positive or the negative could be wrong. And inconsistent means no matter how large your sample size is, it's going to still be wrong. Okay, and that's because you're missing variables, and it's ending up that your error, they're all dropping into the residual, and that's affecting your estimates. Whatever you don't put in the model that's missing ends up in the residuals. And how you check for this in Excel, here's some. So yeah, you're going to have trouble with scatter plots if you have categorical variables, but there's a way to do it one at a time. I guess you can pick one, set one of the categorical variables at a time and look at the relationship of the other variables and see what's missing. Um, so yeah, you want to see what's missing in the residual plot so you can see if you're going to check if there's a pattern in the residuals by the fitted values. If you see um, a pattern, that means that there's information in your residuals that you didn't model. So it's pretty much confirming that your model is wrong. Okay, so we talked about lag variables. We talked about putting in an adjustment for population. So you're missing like larger countries are going to have larger GDP, and that's really what needs to be in your model, and it's missing. Okay, so that's what's going to happen to you. So there's not so much you can do if you're not able to fix the specification. But I just want you kind of to talk about it. I want you guys to make a fair stab at your models. I want you to do your best at taking the best models you found in the papers and finding the data for it. You guys are making valiant efforts in finding data, and I'm very impressed. That's really what I want you to spend time on. The fact that you're not getting exactly, these aren't publishable because you have these outstanding problems is fine. It's just a stepping stone towards the proper models, okay? This is just practice to do these things right, because more and more papers are asking you to do this. Well, let's say journals are requesting or requiring that you do model diagnostics. I guess it's always a standard thing to do, but I just feel like I think I need to stress how to do this, right? And I'm just doing it in Excel, but this can all be done, like Andrew was talking about using Stata. Sure, you can use Stata, but not for this class. I just want you to do it in Excel as much as you can. So then I can compare everybody across, because it's hard for me if somebody's going to use Stata, another person's going to use eViews, another person. I mean, I don't, I'm not, I'm not going to know all of those different softwares to, or are, to be able to judge what you've done. It's like a black box to me. But when I see you doing it in Excel, I can see what you're doing, um, and judge it equally. So anyway, there's the linearity assumptions. If you have autocorrelation, so this could be happening to you because every record, every row of data is supposed to be independent from the other one. But if you have time series, which you have, right? Because you have 2010, you have 2011, 2012. So now they're not necessarily independent because the year before may affect the year today. So now you're violating independence. What does that do? Standard errors are biased. So when you have standard errors, oh, and I didn't even say about linearity. If you have misspecification, your R square is going to be wrong. It's going to be off, okay? With an independence violation, your standard errors are going to be biased. And that's going to give you the wrong t-test, and you're not going to be able to get significance in your coefficients. You're also going to have unbiased. No, you end up having, it says unbiased coefficients if you violate this assumption, but you're going to have trouble finding significance in your variables. So anyway, then there's a way to test this here. I recommended to test time series data. And I want to see you guys make some sort of effort to validate. So check the 5 that you've chosen. They need to be a fair effort. Like I went through with Alexandra, more than Karjit, I think, where I explain you have to, oh, and I guess Karjit and I talked about it a bit too, of having those control variables in there. Those need to be in there to show that, you've accounted for possible confounding effects. Other variables or lurking variables got to be in your model. Variables that influence the relationship between your independent and dependent are there. Otherwise, there's going to be that misspecification problem as well. Again. So anyway, making a table, I can share this table with you, but you guys can make this yourself and see how to check it. Here, this is all I wrote. Make a table. I'll put it in the chat. You guys can do it yourself and play with it. Make a table listing the 6 assumptions of ordinary least squares and the way they can be checked in Excel. Also include a column of problems with the results when the assumption is violated, like bias and coefficients. So anyway, you guys can just copy that. I'll just put it in the chat. So you don't need a textbook. You don't need to watch Z statistics and all the time, like, on repeat. Just you can get that from AI and a nice table. I'm honestly, this is just excellent that you guys have this resource now. Okay. And so these are the assumptions. So linearity, independence, so no autocorrelation, homoscedasticity, that you have constant variance in the residual. So this is doing a residual plot and looking to see that you don't have a funneling. It's just everything is around zero. There's residuals are just fluctuating randomly around zero. It's hard to see, but then if you have a homoscedasticity violation, you're going to have a problem with your standard errors again, and you're going to have a T. So it's going to be a problem with the standard errors that will make it impossible to find significance in your coefficients, and a problem with bias coefficients, the signs being wrong. So those are the 2 standard things that are going to affect your model. And if number 1 is violated, you're going to have problem with your R square because you're missing variables. And number 6, sorry, if that's wrong, you're going to have problems with your R square. So yeah, so homoscedasticity, normality of residuals, you want them to be normally distributed. There's ways to check that. No multiclinearity. You can't put 2 variables that so you guys are going to use dummies. You got to make sure when you use dummies to avoid multiclinearity. You guys know about this? To avoid multiclinearity, when you use dummies, you have to leave one of those out. One of those. So you guys created a variable, like you have all the years, 2010 to 2021. Is that what you have? Or did you have 2000 to 2010? I'm sorry.
I had the decade from 2010 to
And
2020.
20. Okay. So one of those has to be left out, or you're going to have multiclinearity. So one has to be left out, and then all the other ones are interpreted relative to the missing one. We can talk more about that in private if you need to do that. But anyway, so these are the problems it's going to create. This is how you check for multiclinearity. In Excel, you can do an inflation factor. You can put a column of inflation factors, and you guys can read about that. I'm pretty sure he goes over in that statistic video. And all right. The other problem is endogeneity. Okay, so what is endogeneity? Do you guys know what endogeneity means? So Christopher, you're making a model that's like a demand. Sorry, it's demand, right? It's the demand for
Mhm.
exports.
Yes,
And demand and supply are related, right?
yes,
So usually those are studied in tandem. Demand and supply and equilibrium are studied together because it's a structural model. It's 2 equations that interrelate. And because of that, you have, well, I'm trying to think, if one variable, so your independent variables are supposed to be independent. If one of your independent variables depends on exports, then you have an endogeneity problem. It's like looping backwards. They're supposed to be really independent. And when they're not, if any of your variables depend on exports, it's wrong. And that can create a problem as well. So I hope I'm explaining this. So does this all sound familiar to you guys? So these are the assumptions of ordinary least squares. So I, in this class, I really wanted to effectively make you aware of these, how to test for them, to play with them. You know, you have a few more weeks before your paper's due. You have most of the meat of your paper, but this is what I want you to spend time on right now, okay? Testing these assumptions, and then you don't have to make perfect models. You just talk about, okay, so this is wrong, this is wrong, this wrong, and then how to fix it. So how to fix, what kinds of measures can you take to fix this? So you're gonna, it's like another table that needs to be made where how, I think I made this before. So there's different kinds of panel data. Like what problems in modeling or the ordinary least squares assumptions does panel data analysis correct for? What does um you know, because you guys did it with Z statistics where he introduced model specification. He's like, oh, you have to square this variable, or you have to create categorical variables, or you have to logarithm these variables. Like it was all transformations to essentially improve your model specification, right? Those were the steps that were taken. But he still kept it as a linear model, and he still used ordinary least squares. But more sophisticated types of modeling, like structural equation modeling and panel data analysis, and we talked about factor analysis last week. So these sorts of methods, econometric methods, will improve upon the shortcomings of ordinary least squares, things that you just can't correct for. So what we can do, so it's almost 7. Let's take a break. Let's take a break, and I'll pick up with Christopher and then go to Andrew. Let's just take like 10 minutes. Did Annalore show up?
Professor, I'm here. It's George.
Hi, George. Okay,
Georgia, Georgia,
so let's just take 10 minutes, take a break. When we come back, it'll be 5-2. Okay, let's just take a quick break. And when we come back, we'll talk a little bit about those models, those types of models, and we'll just continue with our conversation about what, you know, what you guys are running into. But for sure, Christopher, you have to think about controls. Go back to your papers and look at the variables they put in there. We already talked about a few of them, and just do your best trying to model that. And then I want you to pick what would be your best model of the ones, I don't know how you classified it as the best with the highest R square maybe, or the one with the most meaningful coefficients, and then analyze it. Do the diagnostic check. I don't expect you to do diagnostic checks on all your models. Just pick one.
Oh,
And
Professor, that was what I was gonna ask because
yes, just pick, but
that part
justify
takes
which
a
one you
long
do.
time.
Yeah, no, don't do all 5. Just do one, but make a rationale why you're picking it and do the diagnostic checks. And then I want you to present them in the appendix, but I do want you to mention them in your paper. And then what I want you to do with recommendations, mention improvements. What, as opposed to ordinary least squares, you think that you should do structural equation model, and maybe find another reference for how someone else did it properly. You guys are probably reading papers about panel data analysis, so just mention this should be a panel and why. Okay, so that's it. That's all I want you to do. So let's take a pause. I'll be back in 10 minutes.
Perfect. Thank you, Professor.
Okay, I sent you in the chat just what we discussed, I guess a summary or the table that I showed you that I generated in AI, which I'm satisfied with. I just added one more table. I'm going to send it again and it's called revise. So do not download the one I sent. I'm going to resend it and then show you something else. I'll send it as a Word document. So the one that you want to keep is the one that says revised on it. Again, you guys can generate this yourself, but I guess you feel more confident it's from me. And so that's just the table that I generated. And now I generated another table and I added at the bottom, like the whole thing about R square and the importance of the assumption number 1 and 6, how they influence or affect R square. So you can have a look at that. And now I want to show you just how you can generate a list. I don't know how to do this. I don't think it can list the whole thing, but I'll just show it to you and you guys can generate it yourselves and figure it out. Let me project. All right, so here again, and you can use whatever AI you like. I really like Grok. It seems to be served my purposes. So I just asked it to give me a list of different kinds of regression methods. And Z statistics talks about some of these too, right? So if you have a violated assumption, how do you correct for it? So using weighted least squares could correct for heteroscedasticity number 3. Okay, and he talks about how to do that. And I don't think that's too hard. You guys could make that adjustment. What specific problem it solves, non-constant area variance, which is heteroscedasticity. And then I listed on the Word file that I sent you the add-ins you could introduce into Excel to help you perform these corrections. Okay, so you guys can look at that. So I've given you a few things to do. Autocorrelation heteroscedasticity can be corrected with GLS, generalized least squares, and if you can't do it in Excel, I don't expect you to do it. Sorry, just getting a call. And okay, again, more corrections for heteroscedasticity, autocorrelation. So these are the things that you can do. All right, so if you violate endogeneity number 6, so this is where you do like structural equation modeling, where you're going to do GMM or two-stage least squares, or methods, maximum likelihood methods, instrumental variables. If you never heard about these, you will hear about these, but these are correcting for the problem of endogeneity. And you could do this using Excel. I don't expect you to do it at all, okay? I just expect you to recognize that it's something that you would need to learn to do to correct for an endogeneity problem. And these are econometric problems. These are problems for economic data, okay? And these are developed methods developed to deal with econometric data. Then there are when you set up panels to fix to deal with omitted variable bias caused by time invariant observables. So from year to year, so if you have time series data from year to year to year, something, so we talked about autocorrelation being a problem that because data is supposed to be independent from, the observation is supposed to be independent, but from year to year, some things stay the same. Some things stay the same, right? Like there's just some characteristics from the same country that are the same. The GDP is about the same, and the other variables you might have are similar from year to year to year. And if you're talking about customers or industries, they're going to stay relatively the same. So you want to be able to model that. And so that would be known as a fixed effect, and you would want to control for that. And panel data will accomplish that. And that's actually a omitted variable bias. Number 6, violation. Okay. And how do you correct for that? They say demeans the data or use panel data anyway. So again, I don't expect you to do it, but if you guys can learn the names, then you can go deeper and learn how to use these methods. And so, but as long as you've set up the data and you know how to set up the data, you could learn to do any of these. The main thing is that you understand why you would do that. Okay, that's what I want you to get out of this paper and this class. You're going to do it because it violates ordinary least squares assumption, number 6. Ridge regression. So these are all sophisticated here. Okay, so that's what I wanted to get you to do. You guys can generate that yourselves, or I can try and, you want me to try and make a Word document with it? It's just like so big. I can't, I have to take a picture of it. Anyway, I have to figure out how to expand this. Oh, maybe that worked. No, that didn't work. And I can't download it as a table. It doesn't work for some reason. Oh, here, like I can share it. Share. Are you guys all in Twitter?
Professor, I don't have social media. I only have LinkedIn.
Me neither, Professor.
Okay, yeah, one day you guys will be there.
Not at Twitter.
It's okay. I will figure out, but you want this table? Because I can figure it out and I'll send it to you later.
Yes, please. That'll be great.
So you guys are following and appreciating what I want from you at all? You getting it?
I think so. I think that's
This is it. I just want you to be able to figure out if you violated the assumption. I mentioned in here, so let me make this a little bigger so you can read it. You can install these add-ins to Excel.
nice.
Apparently, I've never done it, but you should be able to, and they'll be able to help you validate those tests on the one model that you pick with justification that you want to test. And then you're going to suggest in the recommendations how to fix it. And that's it. Okay, so I'll try and get this table downloaded for you. Have you seen some of these before? Probably in the papers you read. Ridge regression, difference in differences, random effects, fixed effects, model data, instrumental variables. So ARIMA, that's time series, correlation. Oh, that's
Yeah.
Victor was looking at.
I've seen that a lot, the ARIMA.
Okay, but now you know it's fixing a autocorrelation problem.
Okay.
Okay, that's what I want to gather. And the anything you can do to improve, even try and model these, the better. There are instructors on YouTube. I think Zed Statistics is the best one, but he doesn't go, well, maybe he does do some of these. You guys can look into it should you need it. But okay, so let's go back to, so I'll figure that out during the next break. Let's go back to Christopher and talk a little more and then go to Andrew. Oh, Christopher, did you want to talk some more?
I pretty much took the notes that I needed. I want to make sure because What I'm thinking is since I pretty much, once I make the dummy variable for 1 year, I can just recycle that 1 0 and just switch the country. So I need to figure out how to divide it because I don't want to mess up the data. But I think I'll just have to look for a way to.
But
I
what did
got
what
the
did the papers do? How did they do it in the papers you saw?
well, they didn't. The thing is with the regression models on the paper, they didn't use my the variables that I use, they didn't use it in the way that I'm using. For example, the papers they would use exchange rates and then focusing on just the performance of tea exports in Kenya specifically. So it's models that are not comparing countries as I am. So the way that I organize the data, I try to emulate the relationship that I did, but then I stumble upon the problem that I am now discussing that by the way that I codify it, now I need to, instead of using the numbers that I did, just go like you said, 1 0 1 0 per each country, and then exclude and compare based on the one that I'm excluding. So I just need to reorganize what I have and then and of course add population that I thought GDP would be enough for me to just use it in the demand and supply function using GDP as income, but I'm gonna have to use population for the control to sort of make the model more robust because the models of the papers that I have, they are using GDP or auction price, which I have all that information. What I do need to use in my case, since I'm just using one daycare, I'll have to use the population for the in the case of the US, the census is every 10 years. So by using 2010, I'll be able to just shift the population all the way through. But in the case of Russia and China, in some of the data that I have, there are years where they didn't report some of the data. So I had to just sort of try to keep the same values because the variance wasn't that significant. So I'm trying to use, for example, one of the data that I have when it comes to the exportation team, there's a column that says mirror. For example, how much the exporting country reported versus how much the importing country received. So like an audit, so to speak. So all the countries, even the US, they're not 100% an exact match, but there's a variance. And I suppose that's to be expected. A lot can happen on the way, on the transportation. But I need to figure out a way in the case of the model that I'm trying to use, which is the baseline, which is the one that I suspect is going to be the strongest model that has to do sort of like the demand or supply function of it. I just gonna have to use the better coding of the data. Figure do the I thought I had done the dummy variable by putting the numbers, but I realized that no, it's incomplete. I just need to do it better because Excel basically threw it off because I didn't do it the way that it was supposed to do it. But that's okay. That's what I'm here for, just to learn to code the data better. And then of course I'll just add population. And in the terms of exchange rates, they already have the local currency unit. So the exchange rate is in the relation of the local currency units in compared to the US dollars. So in this case, I don't think we'll have to do the reconversion because they already give me the ratio of local currency units. So I'm gonna have to just look for population and then finish setting up the dummy variables actually set up the dummy variable because I did the coding, but I realized based on the feedback that I didn't really do the dummy variables. I thought I did by just putting in numbers, but no. I can recycle it because I'm using the same year, just switch the country. But that's what I need to focus now on. gonna have to just dedicate more time to it.
Okay, and just keep me posted.
Yes.
Okay. All right, I'll switch to Andrew.
All right, let me share my screen here.
Remind everybody what you're working on.
Sure. I am testing the Albert-Berry hypothesis with USDA census data on agricultural productivity versus land size. So the hypothesis is that as land size increases or farm size increases, agricultural productivity per hectare decreases. This is based on a 1970s study, and there have been many iterations on this specific hypothesis. I am doing a more simple version because the actual equation that Barry uses to calculate agricultural productivity per hectare is a bit intense and would take a few months of work in addition to this class to probably do something similar to that. But I have some ideas of how to um, make kind of a more modern take on Barry's calculation of agricultural productivity. So in terms of my paper, there are some data points in which I will be kind of tabulating some of this data and presenting it, including that doesn't really have to do with the regressions or the models, but it is relevant to the topic, including the number of farms in Puerto Rico. The earliest census is 1910. So we have all the agricultural censuses from 1910 to 2022. The ones I used for the economic
Sorry,
regression
Andrew, can you
model.
make it a little bit bigger? I'm just
Oh,
very
sure.
small for me. Oh,
Let's see here.
just straining my eyes to see it.
Sure. Is it a little bit bigger now?
Yeah, yeah. It's great. It's great.
Okay, so I've got 1998 to 2022. There was a significant change in the way the census was configured, and so there is some standardization from 1998 onwards in terms of the categories of land size. So that is why I went with 1998 to 2022 for the census data used for the economic regressions. But I did pull data on the number of farms, which you can see a significant decline in the number of farms since 1910, a significant decrease in the land in farms. Um, and I have average farm size, which is also an important indicator. I like to compare to other countries in the region, Caribbean islands, in terms of the average farm size. So I just kind of did some basic math here on the decrease in the number of farms, reduction of farms as a percentage, just from one census to the next to see if there are certain decades in which there was a significant reduction of farms compared to others. So this is just some kind of introduction level data that I'll include um, in my paper. So in terms of the number of farms, decline of 87% the number of farms, a 76% decline in the amount of land in farms, and a significant change in the average size of farms, which increased by 182% from 1910 to 2022. So I'm curious to basically pull numbers on productivity per hectare to see how that changes throughout the decades. It's kind of the gist of this study, looking at 1998 onwards. However, I think some future study of this, for example, if I were to use this for a dissertation, I would delve deeper into the earlier censuses and compare that decade by decade, and implications of agricultural public policy and other types of lenses that you could take to see how that might affect changes in terms of farm size, land in farms, etc. So it's just some introduction data. I have it organized here by different components, including like the inflation. I use the CPI, and I use 2022 as the baseline for calculating inflation, and making sure that we're comparing apples to apples on crop sales. I used the USDA agricultural census is very extensive and provides an enormous amount of information. So this is just one fraction of that available data, but does provide some opportunities to go deeper on some other topics that are related to this. So there is reported information on the total number of sales that is divided into two main categories: crop sales, so plant production versus livestock sales. That is also broken down by categories of land size. So they're organized in the census by less than 10 acres, 10 to 19 acres, 20 to 49 acres, 50 to 99 acres, 100 to 174, 175 to 259, and 260 plus acres. So you actually have the number of farms in each of those categories, the land in farms, and I calculated the average farm size of each of those categories as well. We can break this down further and look at sales by size, by farm size and type of sales, either crop sales or livestock sales. I'm using these for different models. And then I also, to make sure that we're comparing these numbers fairly, adjusted for inflation to 2022 numbers. Just some more calculations. So I sort of brought these all together on this panel data.
Yeah, can you make it bigger? Sorry again.
Oh, sorry. Yep, I've zoomed out on this one. All right, so I've got the size class, land in hectares, so a conversion from cuerdas to hectares, land in farms, also sales value to 2022 numbers, adjusted to 2022 numbers using this consumer price index. And then I have the output per hectare. That's what OHA stands for. So I have the total, and I also have broken down by crops and by livestock as well, which are numbers that I use in my models.
Okay, so what is your dependent? Is it the output?
Yes, the output per hectare.
Okay, and your records will be by the farm type or would it be by farm?
It would be by farm type, so farm class. So for example, in my first model, um,
So your panel is going to be year and farm class.
correct.
Okay.
Now I have the same issue.
Can you explain it to them? Because maybe they don't know what a panel is, so you can explain it.
Sure. So, the reason why I need to break these down into specific categories is because, and the reason why I do a log type of calculation is because oftentimes this type of relationship is not linear. For example, and this is totally dependent on location, the country, climate, so many factors when it comes to agriculture. Could be that small farms, very small farms under 10 acres, could be less productive as a 10 to 20 acre farm. So it could be more like a bell curve instead of a linear relationship. So that is why I'm doing a log, specifically looking at log calculations of average farm size and then comparing that to the output per hectare. There are other ways to calculate output per hectare that take into effect the cost of labor, capital, irrigation, whether the land is owned by the operator or not, or whether it's leased. Those are other important factors and things that many people have brought up in terms of when I did my literature review. People like, critics of Berry's hypothesis have asserted that there are some other factors that are not taken into account when you look at output per hectare. So the reason why I break these down is precisely for that reason. There's a huge variation on types of farms. For example, the large farms over, these last three categories, for example, I saw just anecdotally by going through each of these censuses and inputting this data, I could easily see that there's a point in which probably around this 50 to 100 acre category for farm class that most farms are majority livestock. Most of the farms that are under 50 acres are mostly selling crops. Um, and so you see that just in terms of the market value of crops sold. Um, so that's the reason why this is broken down into farm size. Now you could also break this down into farm type. You could break it down by the USDA region. There are, I believe, 9 regions by the USDA census. I used those regions for a separate, when I was looking at my master's thesis data, broke it down by region. There are different results, some that are statistically significant, others that are not, but broken down by region. So that would be pretty interesting to do as well. So there's some many ways to go with the USDA agricultural census and how to test this hypothesis.
So
Um,
because your
yeah,
hypothesis is about size, it's logical, no, to do it this way, right?
absolutely. Yeah, because not all farms are selling the same value of crops at a small size versus a large size. So those are some important factors. Also, an important factor to note is that not all of the acreage that a farm has is under production. And so one way that we could account for that in the future is by looking at a different number that farmers report for how much land is under cultivation. So this is pulling the average farm size, but an important anecdote here is that not all of that land is under production.
Okay. And from year to year, there's more variation between the groups of cuerdas than there are across the years. So this is why you do this, right? Like a pan.
Right. I mean, you could even look at how this compares to the introduction data that I presented on, you see the average size of farms is increasing. Is that because the small farms are not as profitable, or those are more susceptible to certain risks like climate change? I mean, there are all sorts of questions that we could test with this data as well, just because we have it all broken down pretty neatly within the agricultural census by class size. Um, I have the same issue as Christopher in that I did not create dummy variables. I converted my categorical variables to numerical. However, I didn't actually do a true dummy variable. So I'm curious how that will change my results of my models. But this is me converting these to numerical, but I did not do the extra step here of creating a dummy variable with that, which is now on my to-do list. Um, did the same thing here for farm size, since this is a size class of farm, categorical and converting that to numerical. Um, these are my other data points for this specific model. Model one is the simplest one of just looking at the relationship between um, output and farm size, average farm size per class, and the log of that, which the data actually does. The results, I'll go to the results section here. So this model one does indicate a strong inverse relationship, which would be consistent with the Berry hypothesis. Now, might want to take this with a grain of salt because I need to obviously create these dummy variables. I could be interpreting these variables as numerical. So I don't know how strong that inverse relationship will be when I um, properly input these dummy variables.
So you run this just as a regression and you just have average size there. You didn't do anything with the years, right? Like, where's your model? Did you write it at the top? Like, you just have your dependent being output and then size. You just have one variable.
Yeah, I'm only comparing. This is the simplest one. I'm just comparing these two
Okay.
variables.
You have to have three. I told you you have to three. So
I need
when
to have the third one. Okay.
Barry's, huh? In Barry's modeling, didn't he have control variables or?
Yeah, there are a few fixed effects. That's also on other models. I have other kind of fixed effects, and then take into account like capital labor and irrigation. Those are ones I haven't run yet, but um,
So I want you to use
yeah.
at least three variables. So you're gonna you're gonna have to start with the three. Um, but see, you're running it as ordinarily squares. He's using panel off the bat. Just wondering, you can run it as a panel. I would be fine with that. Um, and you can do it in Excel. I thought that's what you were doing, running it as a panel in Excel. Um,
So is that in the same function? Like the same?
it is I'm gonna send you here. I'm gonna send you a link. This guy describes how to lay it out and everything on Excel. It's a YouTube video, and you can try that out and then let me know if that helps. But yeah, just do it in Excel. And he models everything, the dummies and everything. Like you'll see it all make more sense when you see what he does um, in Excel. And I'll send it to you. So just continue talking. I'll send you the link in the
Sure.
chat.
Yeah, so this one I will account properly for the dummy I mean, can I use those two dummy variables as controls, or do I need to add a separate variable like a fixed effect?
Sorry. Uh, yeah, it's fine. It'll be one of your variables and it's fine. It'll satisfy my requirement and you're going to be cool. All right. And again, I'm still troubled thinking that this is not exactly international business, but you can spin it that way in the future. And I really like your topic and whatever. So yeah, and you're gonna do this as a panel in Excel and I'll be satisfied.
All right, so I will convert this to panel. The other one, just through the process of originally I had some models in mind, and then as I went through the data collection process, extracting these from the census, um, I wanted to run a comparison of crop versus livestock. I was curious whether this hypothesis would hold up when compared to crop and livestock. So that is potentially one that I may substitute for one of the five other ones. But commonly, so these are the two that I have to present. But the other,
It's a different hypothesis, right? That's a different hypothesis if you did the livestock one. Or is it a different way to divide?
right, I guess
Yeah,
it would
try to
be
stick with
that.
the same hypothesis, the same. Yeah.
Okay, so maybe not that one then.
You're going to be okay, I think, with the one. Anyway, you'll see. Just keep in touch. Look at the Obi Pat video series and let me know if you're lacking from
Okay, that sounds good. So that's kind of the basis of what I plan to do for the last few models. Add another variable for the farmers in the census, also include whether uh, there's irrigation on their farm. That's another one that is often cited as an important variable for productivity. Labor costs is another one, and capital costs. So that's fertilizer, seed, other types of expenditures that fuel, I should say, as well, that farmers spend money on in a year for that may or may not affect productivity, but are often used in these types of productivity analyses. Also, fixed effects will be another good one because specifically this 2018 year is, coming right off of Hurricanes Maria and Irma, and there was a significant reduction. I could just see that as I was going through extraction of this data on the value of goods sold. Very significant decrease from 2012 to 2018. And then you see an increase from 2018 to 2022. So I'd like to take into effect using fixed effects, try to include climate. Another one that I thought of in terms of climate variable would be using a variable, like using a dummy variable for whether it's an El Nino or La Nina year, which typically means
Nice.
it's either extremely dry for an El Nino year and very wet, lots of precipitation in a La Nina year. So I'd be kind of curious to include that as well, and how that affects productivity at different farm sizes. So that was another one I was considering incorporating in some respect.
That sounds great. Okay, this is good. You're on track. You'll be finished in a few weeks, I'm sure. You have all of you guys. I told you you can submit. What was the last day I said? Did I say the what did I say? What did I email you guys? Let me check my calendar. I think the 15th, is that what I said, or the 17th? So you do have a couple of weeks and a bit to finish. But I want you to keep in touch with me about everything, you guys. I want you to be able to do this comfortably on time. Do you have any comments for Andrew, anyone? So so I'm gonna have you look at that. I sent you the link for the Obi Pat Obi series of videos, and he does everything in Excel. He does everything in eViews too, but just watch the Excel. He does it in both because those are popular, but just stick with Excel. Don't worry about eViews. And he shows how to develop, how to how to specify the dummies and how to interpret the results and how to yeah, how to interpret the results, how to basically he goes step by step, so that's going to be good for you. Good experience.
Excellent. Thank you.
And you're going to do the you're going to do the pooled estimates, the fixed effects, and you can do some random effects, and you're going to have a lot of you have a lot to choose from, models and variables, because you're dummies. And Christopher, you can look at that too if you want, but you don't necessarily have to if you haven't figured out exactly what to do there with the panel. Okay. Okay, you guys. Any questions from
Professor, I,
George?
I haven't presented yet.
You didn't, hey? I thought you did.
We talked in Saturday, previous Saturday. That's why.
Oh, okay. Okay, so I guess we can do George. We'll have George. Um, so anybody interested in the panel data videos that you could complement the Z-Stats videos with, there's a series there. I put the link. And what I'm thinking about is I wonder if I'm pretty sure Z Statistics has more videos, but I just really like the regression series, and I guess you could look through there too to see if there's anything else. Okay, we're gonna move to George. George is gonna show us his well, he's gonna recap what he's done, and let's see if
Hmm.
questions or comments for him. All right, let's go.
All right. So as you guys know, I changed a little bit my plan with my models because of some lack of data and because of the intense data cleansing that I had to do. I instead of doing a panel data, I did a cross-sectional. And what I'm looking at is a snapshot in time of 2019. using 3-year lag because the last available DESTA, which is the data set that I'm using for the environmental provisions, the last year they have is 2016. So that's the latest available data. I used a lag of 3 years because from what I saw in the papers, using the lag would allow, a country to start implementing uh, their treaty. So it takes time for them to implement. So I'm taking that into account. Um, when I started doing this, another thing that I had to do was the DESTA. They basically codified all of the environmental provisions that exist, and they have about 219. When I showed that to the professor at the beginning, I had thought of just because this is something that other people did in the papers, just if it had one of them, I was going to count it as, having environmental provisions. But when I showed it to professor told me, um, verify each of those columns because not all of them may be, um, uh, may have a relation to your specific research, which is CO2 emissions and renewable energy. So I reduced the entire all of those columns that I had and picked 33 that are the data sets that are really align with the hypothesis that I have and the model, the theoretical models that I'm trying to evaluate. If you guys recall, I'm using various theoretical frameworks, institutional analysis. I'm using as well as the Kesnet curve, which tests and basically says that in the beginning, when we start production in a country, it'll increase CO2, but then as time passes, uh, with higher GDP, the CO2 is reduced. So that's one of the things that I'm testing. That particular theory is the one that I was able to validate with my models. So out of the five hypotheses that I have. Two of them I was able to validate. The other three, I did not have enough R square to really explain them, as you'll see soon. But I wanted to go over, the data that I have. Um, in the beginning, I only had these data sets until here. And then as I did my models, I realized that I was getting R squared very low. And I was like, oh my God, I'm gonna have to redo all this. I was scared. So I started playing around with what we had in set statistics. So I started adding the logs and I also added GDP per capita square. Um, and I also added um, dummies for regions. It was one of the things that I thought was that maybe some of the countries were, messing up the how the data was showing. So I did these dummies, and basically what I have here is these are the regional categories that the World Bank uses, and basically, these are these six. And for every country, if it belongs to that particular region, then it'll have a one in it. Um, and now let me go. There's another thing that I want to talk to you about. This government index, this index,
You remember you have to
uh,
put one of the dummies out, right? One of the countries out.
yes, I
Region.
left out Oceania. I left out Oceania. This is
They're
the
all
one I left
relative
out.
to Oceania. Everything.
Yes. I'm going to show you that model. Let me show you. This is one of the best models that we have. The R square was 81.81. And in here we can see,
That's nice.
oh, yeah, very nice. But this wasn't my best model. The best model was model number 7, and I'll show you soon. But I wanted to show you this one
Okay.
first. From what I got here, I realized that only Africa really, did something that was showing some level of significance, but the other uh, regional variants that I have, they're not really doing anything in the model. So uh, regional variants are not really, at least in this regression, they're not really, pulling anything, much of anything. The one variable that really um, was impacting CO2 was the renewable energy. Um, the renewable energy, the greater renewable energy, the lower CO2 emissions. The other variables that I've been testing in the different models, for example, the FDI did not have any significant importance. The same for the environmental provisions. Now, I would like to see to use the environmental provisions again using the structural equation modeling, because that way I'll be able to have a better index. Right now, the index that I made is
Yeah,
basically
how'd you make?
out of the 33 variables inside the whole 180 219 data sets, I reduced it to 33. And what I did was I sum all of the for example, let's say if United States had 6 of those, then the United States will have a number 6. And then the highest number will be 33, and the lowest will be 0. Um, Let me show you my descriptive statistics. So in here, for example, um, oops, environmental provisions. So for the maximum that I had was 21. One of the countries had 21. The lowest is 0. But in theory, the maximum it could have was 33, because that's where the amount of variables that I was looking into when I test the environmental provisions index. I also did here uh, another, I'm sorry, I added here a column. And this is environmental dummy, environmental provisions dummy. I did not use this one though, but I had it. And then what
That's just zero,
else?
1. They have a provision or they don't.
Yeah,
Mm.
exactly. But this one, as we talked about when we met, is very simplifying, and it's not a fair assumption. I don't think it's gonna skew my data a lot. So I think this index is much better representation of actually, having some sort of um, explanation. However, when I ran the model, it didn't. So, I would like to later in another course do a panel data once I'm able to clean this up a lot more to include other years. um, I'll be able then to see if across the years, the environmental provisions, my thought is maybe the thing that could be happening is that the lag years that I chose for 3 years might not be the correct ones. It could be that they take longer.
So was your lag
Um,
variable significant then?
um, no,
Hmm.
it was not significant. Um, and then for FDI, it was not significant, and it was also not significant for another variable that I tested was uh, the governance index. This one is one made by the World Bank. And what I was testing here is the capacity for these countries to implement their policies. It also did not reflect um, their ability to reduce CO2, basically to implement the environmental provisions. That's what I was trying to test. But it did not show with the models that I did that there were any significant. Um, so yeah, and that's
So
pretty much what I
for
have.
your 80% R square, what was significant? Remind me. Which one was sig-
So the majority, what I was able to really prove was um, the Kirchnet's curve. Um, and it's basically, let me show you model 7. This is the highest, 82.
like the more developed, the low, no, initially that there's high emissions and then it's lower as the GDP goes up.
Yes. And also, because in here what I did was the regular log GDP per capita and the log GDP per capita squared. So that's gonna give me like in the initial and the later. So it actually shows
I see.
it proves the curve actually happens in the data, like the theory mentioned. And then
That's
the
sat
other thing that I'm sorry?
that's satisfying.
Yeah. I was really happy. I got excited and I kept doing models when I
Yeah,
saw because model
I
5 was actually good, and then I kept doing and I got a little crazy. So I got scared when you mentioned the task because I was like, if I have to do those tests for all 10 of these, I'll die.
oh, just do it for the best
Uh,
one. Yeah, just do it for the best one. That would be great.
yeah, it'll
Yeah.
be for this one for the
And-
7th.
Well, you know what,
And
you two,
here,
George, have a look at that panel data set of series of videos. I don't know what you have planned for the next 2 weeks, but that might be satisfying too, to look at how you can set it up and run the panel. But if you don't have time, I mean, looks like you've done what you're supposed to do, just do the diagnostics and see how it meets the assumptions.
yeah. And that's pretty much it. In the future, I also want to do the FDI. I want to see if I can get the green FDI because I use general FDI. Um, and it'd be great if I could use a specific green FDI, although that's gonna reduce my sample a lot because not there's not a lot of data for every country. Another thing that I forgot to mention, Professor, was that in the models that I used FDI, I had to take out at least, I think there were 13 countries because I didn't have data for them. Like, for example, this one.
Yeah.
Let me s- So I didn't include
So,
those. I'm
so
gonna
yeah, you
do
mentioned
that.
that, right, in your paper that you
Yeah, yeah.
and the
Uh,
implications of losing those countries. Which countries were they? Were they African countries
um,
or
there were some actually we have Namibia, Qatar, Netherlands, Mauritania, Iceland, Iraq, Denmark, Belgium, Austria. These countries are usually some of the strongest in, at least from my thoughts, where some of these are some of the best in terms of
FDI?
green energy,
Oh,
renewables,
okay.
especially Austria. I was in Austria, and they're very good in the green um, transformation
Hmm.
and transition.
But they had missing
Um,
data?
yeah, I didn't have the log FDI for them. Uh, I have to see if I can get that. If I could get that, that'd be better. I think this is another factor that I want to improve when I do this again, to get all
Was
these.
that consistent that you didn't have the FDI or just in some years?
In 2019. That's why
Change a year?
the panel data is gonna give me a lot more information.
Okay, wait, what years did you use for this?
So the only for the Desta, since I'm using the lag, I use the 2016 data. That's the one that I'm lagging. The rest are 2019 data.
Well, have a look if you have another year just to test it. I mean, not for this, but in general, if you check if there's a year that has Austria and Belgium, like it might just be they didn't give the data or something happened because right after that COVID happened and everybody was busy, you
Yes.
know? So they didn't
Yes.
report or whatever. So if you did maybe 2018 and go back to 2015, see if the results are robust or how things change.
Okay.
Do you know, you follow what I'm
That'd be
saying?
good.
But you don't have to do it
Yes.
now.
Yes.
You did all of this, but it would be nice. Yeah.
Okay.
You see what I mean? It shouldn't change too much. That's the beauty of
Yeah.
population data. The results should be pretty stable. And if your model is a good model, then it should be just as good using 2019 and a 2016 lag with it should be comparable to 2018 with a 2015 lag, shouldn't be
Yeah.
so yeah, cool. Very good. Well, that was
Awesome.
a
Well,
high note. So now
yeah.
yeah, so I think you should have a look at the panel to see how you incorporate that. But if you don't have time to do it for this course and just, for future reference, it's a good series of videos.
Perfect. Thank you, Professor.
Okay, George, thank you. Anybody have comments for George? They all send their accolades. They're impressed. They're happy for you. They're happy for
Awesome.
you. Okay, good. The satisfaction, right?
I know. It was good. I feel like this class, the learning curve has been the highest for me, and I think this was the best class. And not to brag, that not to, but honestly, this is like I think the core of the PhD program. This
Oh,
class is just,
well, you haven't just started, but
I know this class is like, like for me, like just the fact that I work writing a paper, and I did my master's in planning, and I remember that for me the thesis was very mentally exhausting because of like, oh, I'm writing a thesis, and I got stuck for a few months, and the way you did this, that we have to write it from the beginning, and we have to like lose all our fears and actually going, I think that's so good.
thank
um
George's
so
my
thank
greatest
you, Professor.
fan ever. George, but George, because you did that painful master's, you can appreciate this. That's the other part.
Yes.
Yeah.
Yes.
Yeah. So I think that's why the timing was perfect for you. I'm glad. I'm glad. So, and you see the end of the tunnel and you had a good result. Wow, look at that.
Yeah, I was happy.
Yeah. Well, you got rewarded. See, because you're so good to me, you got rewarded. All right, guys. Well, thank you so much, George. I'm glad, and I look forward to continuing. We have two more classes still, guys. We're going to continue with our discussions. We're going to see how Hannah Laura's doing, and maybe I can talk a little bit more about regressions and like the panel models, or I don't know. I'll figure it out. I'll figure out where I can fit some more information in that's useful for you guys. But I look forward to seeing more of your developments. We can talk more next week. It's 8 o'clock, right? No, what time is it? Yeah, it's 8 o'clock. Are you guys good to go? Get back to work?
I'm good.
Okay, so let's get going.
I'm
Good
good,
night.
Professor.
Okay, you're good? Okay, you guys. So get back to work, whatever you're working on, and we'll meet again next week. And then we're supposed to meet on Wednesday as well. So I'll have some new material for you. Okay?
Which Wednesday of
All right.
next week or this Wednesday?
We're supposed to meet on the 8th and the 10th to replace some Monday that we lost. So, according to the calendar. So let's see how much material I can put together. You guys can let me know. Like I usually typically when you learn econometrics, it's very theoretical and they do a lot of derivations and I don't know. I left it pretty practical in here. But I did give you in the prontuario and the syllabus all of the references for the theoretical and Woodbridge. And then I gave you some more practical applications with these YouTube videos. And you guys did it yourself, right? So maybe, I don't know. I'll figure out what to do next week. I mostly said what I want to say to you, but we can just do some more applied work. together. Okay, so let's see what happens next week. I'll see you then.
Take care,
Thank
guys.
you.
Thank
Thank you,
you.
Professor. Have a good night.
Guys, good night.
Thank you.